to be active. Those four, and those four, but not these four in the middle. Now, the yellow wire is right here. It connects to these four light blocks. The white wire is connected over here, and the other one, the orange, is down here. And because the orange, the white, the green, and the yellow are activated, that shows 4. Now this display used to be much smaller in the original design, but I decided to make it a little bigger because it's easier to make out what number it displays. But it does, everything here I've added does increase the amount of lag that is produced whenever the number changes. So let's go over back here, and I'll hit the green button again. I'll make it go up to 5. And just to go over everything once more, there are 5 counters that have reached their limit and are sending a signal to 5 wires. These 5 wires activate this row with 5 invert cells and the row of non-invert cells, and deactivate the wire above them. The signal is sent through an inverter, goes through the blue wire. The blue wire is over here. It connects to this row. It activates the 2 non-invert cells in this row. It's 0, 1, 0, 1. Signal sent through the orange and magenta cable. So the orange and magenta cable over here are receiving a signal. It matches the pattern in this row only. So these 2 non-invert cells activate, well, basically deactivate the output from the non-invert cells, which the signal becomes inverted through this row of blocks, and this torch sends a signal through this row, and it turns on these non-invert cells. It's got 5 outputs now, so that's pink, orange, blue, yellow, and green. You already know where the orange, yellow, and green ones are. The blue one is down here. It controls this row of light blocks. So that's how you get 5. Over here, I have made a timer circuit that basically controls it automatically. And as you can see, it has 2 pulse formers. I'm not entirely sure why I have this pulse former connected to here. It does nothing really. But in any case, this timer here, I have it set for 1 second and 200 milliseconds. So let's take some time off that. I'll make it a 1 second interval. So every 1 second, it'll send a signal through this white cable, which sends a signal to all of the counters. Now, one thing you should know about the counters is once they have reached the maximum increment that they can go to, they cannot receive input from this side anymore. So no matter how many times the signal passes from this white cable to this counter, it will not do anything. If it receives a signal from this yellow cable, it will go back down to 0 because I made the maximum decrement 4. Alright, so let's go back here, back to the timer. This is another counter. It counts up to 10, however. 10 because it goes 0 to 9, so it's 10 digits. And right here, every time this sends a signal, I already said that it goes through that white cable, it also goes into this counter. And because it's only one signal being sent at a time, this counts up evenly to 10. Once it reaches 10, it stops. It'll actually send a signal through this torch here, through this yellow cable, and activate this toggle switch. The toggle switch you can see its output is now this side, so it's going through this pink cable. Once it reaches 10 and gets a signal, it switches over to this side. It goes to yellow, and that will set this back down to 0. But the yellow cable also goes through a pulse former here. Now the pulse former sends a signal through the other side of the toggle switch so that it goes back down to this, and that resets this counter, which this was pretty simple to figure out. I didn't have much trouble with this like I do most things. So I'll get rid of this torch and have this count upwards. It works pretty good. However, it goes a little fast and there is a little bit of lag when it counts. That's basically how everything works here. The only thing I can take credit for in any of these setups is these two buttons that increase and reset, this timer circuit, this counting circuit, which is really massive and can probably be shrunken down by someone who knows a little more about what they're doing, and this here. Everything else, like this translator and this display circuit, were done by someone else. And this was originally a 7-segment display. Now over here, I have not done any of this. This is from someone else's map that I downloaded. I just wanted to see how they got everything to work. And as you can see over here, I have a bundled cable attached to this. This was how I originally designed the counting circuit over there. Only difference is I made it vertical to save a little bit of space, which really I could have stacked the two on top of each other and that would have worked also, but I wanted to try doing it vertically. But it basically does the same thing. As you can see, I had this set up to 2 inputs, one for counting up, one for reset. It's counted to 1, so it's just got this one light block turned on now. It's all pretty simple. I may go over how to build one yourself in case you are still uncertain of how to build this. All depends on the comments I get. If I get any requests to do a video on how to build it, I will go over that. But the only difference is I will not go over that in creative mode again, because trying to orient these in creative mode is such a pain. You cannot use the screwdriver for, like you do in survival, to change the direction of those integrated circuits, so it makes it a lot harder to do. So now that it's night, it looks pretty nice. And really the only problem with light blocks is that sometimes the lighting on them becomes messed up. I'm not entirely sure why that is, but I have a feeling it has something to do with Notch's addition of the brightness setting for Minecraft. I guess all these blocks and plates retain the same information since before the addition of the brightness setting, so they'll get pitch black unless you apply light, and even when you do, they do not appear as bright as what they should. So that's all for this video. I hope you enjoyed taking a look at how this is all put together. I'm not a genius when it comes to redstone, so it was quite interesting to be able to design this based on just the pictures of someone else's design and have it able to work. It was pretty interesting. I learned a little bit about the null cells, how they work, counters, pulse formers, and binary coded decimal. So can learn quite a bit from building this yourself, and who knows, maybe you might want to try it yourself. That's all for now. Take care.